Robert Hooke's name may not ring as loudly as Newton or Galileo, yet his influence on science is immeasurable. Born in 1635 on the Isle of Wight, England, Hooke was a polymath, an architect, inventor, astronomer, physicist, and the man who gave us the term cell. He was one of the driving forces of the 17th century scientific revolution, a restless experimenter whose curiosity touched nearly every field of knowledge. But despite his brilliance, history has often overlooked him, partly because of his fierce rivalry with Isaac Newton, and partly because no portrait of him survives. Still, Hooke's ideas helped shape the very foundations of modern science. Hooke's early life was marked by frailty and fascination. A sickly child with a sharp mind, he built mechanical toys and clockwork models to amuse himself. He entered Oxford University as a chorister and soon came under the mentorship of the great chemist Robert Boyle. Working as Boyle's assistant, Hooke designed the air pump used in groundbreaking experiments on gas pressure. His precise engineering and observation led directly to Boyle's law, one of the cornerstones of modern physics. Even then, Hooke's creative genius was already changing how science was done by uniting imagination with experiment. In 1662, Hooke became curator of experiments at the newly formed Royal Society of London. His job was to design and demonstrate new scientific experiments for the Society's weekly meetings, an appointment that perfectly suited his boundless curiosity. He built instruments, conducted studies on mechanics, optics, astronomy, and biology, and published his findings in ways that made science vivid and visual. His most famous work came in 1665 with the publication of Micrographia, one of the most influential scientific books ever written. Using a microscope of his own design, Hooke revealed an invisible world, detailed drawings of insects, plants, and minerals that astonished readers. In one of these observations, he examined a thin slice of cork and noticed tiny, regular compartments. He called them cells, comparing them to the small rooms occupied by monks. With that simple observation, Hooke gave birth to the field of cell biology, a term and discovery that would echo through centuries of science. Hooke's contributions went far beyond biology. He formulated Hooke's law, the principle that the extension of a spring is proportional to the force applied to it, an equation still central to engineering and materials science. He studied the motion of planets, proposing that gravity was an inverse square force long before Newton made it famous. He also invented the universal joint, improved telescopes and barometers, and conducted pioneering work on elasticity, combustion, and light. In architecture, he collaborated with Christopher Wren to rebuild London after the Great Fire of 1666, helping design landmarks such as the Monument and parts of St. Paul's Cathedral. Yet Hooke's brilliance was matched by his misfortune. His fierce rivalry with Isaac Newton over the nature of light and gravity became one of science's most bitter feuds. Newton, who later became president of the Royal Society, allegedly suppressed Hooke's reputation after his death in 1703. The only known portrait of Hooke disappeared, and for centuries his name was largely erased from scientific history. In recent decades, however, historians have restored Hooke's rightful place as one of the founding fathers of modern science. His methodical experiments, visual documentation, and mechanical inventions set a new standard for empirical research. Hooke embodied the experimental spirit of the scientific revolution, curious, creative, and unafraid to question established authority. Robert Hooke died in London in 1703, but his legacy endures in every microscope, every measurement of motion, and every scientific principle grounded in observation. He was the ultimate Renaissance experimenter, a man who saw what no one else could see, and in doing so helped humanity understand the hidden order of nature.